Okay, here's a question where you're asked to solve this for x. I want to find all the values of x that'll make this true. Now, if I were to write this as a function, x squared minus 10x plus 41, I would know that the solutions to this function, like looking at that thing called the discriminant, and the discriminant we had was b squared minus 4ac, and we said if that came out to a greater than 0, then the quadratic function would cross the x-axis twice. If it came out to equal to 0, then it would just come down and touch the graph once. But if the graph came down and was less than 0, or in other words turned out to be a negative number, then the graph would not cross the x-axis at all. So this answer here has the potential to be this, this, or this, and we'll see what happens. Now, I could solve this in a number of different ways. I could try and factor it, but there's no way I'm going to get 41 things that multiply to 41 and get a 10, so I'm not going to factor it. So I could use a quadratic formula, or like I showed in the homework help, you can use complete the square. So complete the square, you move this over to the other side, so you get x squared minus 10x is equal to negative 41. And then to complete the square, what I'm wanting is on the left side to get a perfect square, something that I factor and I get the two same factors. To do that, you take this number here, the negative 10, I'll do it over here, take negative 10 and divide it by 2 and then square it. And that works every time to complete the square. So what you come up with that is 25. So I can add 25 to this side, and I do that on the left side, I have to do that on the right side. So on the right side, I come up with negative 16. On the right side, if I factor this, it'll be x minus 5 and x minus 5. See, they're both the same, so that's a perfect square. I can write it like this. Okay, now I can use a square root principle on both sides and have a plus or minus over here. So on the left, I have just plain x minus 5. On the right, I have the plus or minus square root of negative 16. Now, you may not have worked with the square root of a negative number before. In Math 20, typically we look at a little bit at complex numbers. But if you have a negative under the square root sign, what you're looking is that right there, because that's part of your discriminant, right? And the discriminant came from the quadratic formula, and the discriminant is the thing that's underneath the square root sign. So if it's less than 0, what you have is a quadratic function that does not cross the x-axis. And I can tell that because there's a negative number under the square root sign. Okay, so that's one thing that I know about this thing. But I can also simplify that. Let me just rewrite this again. So the square root of negative 16 is the same thing as the square root of negative 1 times the square root of 16. Okay, that's just a rule. You can separate those. When you deal with complex numbers, we define the square root of negative 1 to be an I. Okay, so I have a plus or minus, and the square root of 16 is 4. So really I have x minus 5 is equal to plus or minus 4i. Now I'll add 5 to both sides. So I get 5 plus or minus, we'll just change the order here, the commutative property. So my x-intercepts, I guess I can't call them x-intercepts, but my zeros of this function, or the solution, is equal to 5 plus or minus 4i. And because of this I, the I indicates to me that this is a complex number, or an imaginary number, sometimes we call them. And it also indicates to me that the graph does not cross the x-axis. Now, if you were to use the quadratic formula, this one, I should get the exact same answer. Let's try it. So minus b plus or minus square root b squared minus 4 times a times c all over 2 times a. Okay, so b is right here, negative 10. So negative 10, B, no, A is a 1, and C is a 41. Okay, and then A at the bottom again is a 1. So minus a negative 10 would be a positive 10, plus or minus square root. Negative 10 squared is a positive 100. 4 times 1 times 41, 161. Is that right? I'm just checking to see if this is right. 4 times A times C. Yeah. So 164 it is. 164. So minus 164 all over 2. Okay, I'm not there yet. So x is equal to 10 plus or minus. This will be the square root of negative 64 all over 2. Now that's square root of negative 64. I can do the same thing as I did right there. Let me continue down. So I get x is equal to 10 plus or minus. The square root of negative will be an I. The square root of 64 will be 8 all over 2. And then I can divide, the 2 is a common denominator, so I can divide the 2 into both of those. 10 divided 2 is 5, plus or minus 8 divided 2, 4. Same answer. Okay, so again, this introduces you, maybe, or reviews the idea that when you take the square root of a negative, you can rewrite that as a square root of negative 1 can be written as an I. But that indicates that it's an imaginary number, and again, the graph won't cross the x-axis.